Topic 2, Day 1, Linear Functions. A few important linear function characteristics that we need to keep in mind is first that our parent function is our function y equals x. As shown in this graph here, you'll find that both the x-intercept and y-intercept are at the point 0, 0, otherwise known as the origin, and that the domain, all the possible x values, is all real numbers, as is the range. So you'll see that this symbol here means all real numbers. Right? And again, domain represents all possible x values, right? And that our range represents what all the possible y values are. Slope is what we're probably used to hearing, but in IB, you'll also hear the word gradient thrown around. They mean the same thing. They represent the steepness of a line, and gradient measures how much a line rises vertically compared to how much it runs horizontally, hence rise over run. The equation y2 minus y1 over x2 minus x1 can be used when you're given two coordinate points, right? So you need some x1, y1 value, and then x2 and y2 value. There are multiple forms that linear functions can be written in. Slope-intercept form is very common, where m represents the slope or the gradient, and b represents our y-intercept. Point slope form is useful because it can be written with a coordinate point, x1, y1, and then standard form is also available. When we talk about parallel lines have the same slope. Very important. Parallel lines have the same slope, but they have different y-intercepts, all right? So parallel lines never intersect with each other. So you'll kind of imagine lines that look like this. And on the lines themselves, you'll often see this symbol where the arrow is in the middle of the line, not at the end. And those red arrowheads represent parallel. It is telling you these lines are parallel, okay? Perpendicular lines have opposite and reciprocal slopes. What that means is their signs are opposite and their fractions are flipped. So for example, if we have a slope of 2, you can rewrite the number 2 as a fraction 2 over 1. We know that 2 over 1 is a positive value. So its perpendicular slope, which we're going to use this symbol right here to represent perpendicular, we know that slope is going to be negative, right? Because they have to have the opposite slope. So positive becomes negative. And then we're going to flip our fraction. So 2 over 1, the reciprocal of 2 over 1 is 1 over 2. That means our perpendicular slope is a negative 1/2. Teacher example number 1. The equation of a line that we're going to name L1 is expressed as 3x equal to 12 minus y. So this equation, 3x equals 12 minus y, is not in a form that we are currently familiar with. So we're going to have to do some reorganizing most likely. We're going to find the x-intercept and the gradient. So let's start with that. In order to find the x-intercept, we can always plug in 0 for y. Because if we think about any kind of line here, right? At the x-intercept right here, we'll see that your y value is 0. Okay, so if we plug in a 0 into our equation here, we get 3x is equal to 12 minus 0, and that goes away. Solving for the x, divide by 3 on both sides, x equals 4. That means the x-intercept has an x value of 4 and a y value of 0. Unless explicitly instructed otherwise, your x-intercepts and y-intercepts should be written as coordinate points. Okay, now we're going to look at this equation, and in order to find the gradient, we can get it into slope-intercept form. So if we get it into the form y equals mx plus b, so get y all by itself while moving everything else to the other side, we can find out what the slope is. So I'm going to add y to both sides, and you get y plus 3x equals 12, and then subtract 3x from both sides. Y equals negative 3x plus 12. Now it is in slope-intercept form. I know that my m value here is negative 3. So I know that my gradient here is negative 3. Now, a second line, L2, intersects the x-axis at this coordinate point to 0. And it is parallel to L1. That means same slope. We're going to write the equation of L2, giving your answer in the form y equals mx plus c. All right, and we're going to see that's the same as y equals mx plus b. It's just that the constant c or the constant b represents our y-intercept. Now, I'm given a point 2, 0 that it's going to go through, and I'm given a slope. So it's really useful here to use our point slope equation form, y minus y1 equals mx minus x1. We're going to plug in all of those values. Y minus 0 equals negative 3, x minus 2. Obviously, this is not in slope-intercept form yet, so we need to do a little bit of simplifying. The minus 0 will go away, and then we're going to distribute our negative 3. We get negative 3x plus 6. And that's our equation in slope-intercept form. And then lastly, it says calculate the y-intercept for L2. Because it's already in slope-intercept form, we know that that 6 value is your y-intercept, right? So we can say that it is at 0, 6. But if you weren't sure and you wanted to double check, we can also plug in 0 for our x value. So we can do y equals negative 3 times 0 plus 6. That will cancel out, and then you'll get y is equal to 6. All right. So there are the solutions for teacher example number 1. Take a little bit of time and try student example number 1 on your own.